Welcome to Structural Analysis 2 video series, unit number 2, Moment Distribution Method. Lecture outline, Numerical on Sway Portal Frame, Part 2. So this was our problem statement, and this is a continuation of a previous video. So as so far what we did, let's take one review of that previous lecture. We gone through the problem statement. So this is our problem statement, that we have to do the analysis through the moment distribution method and draw the bending moment diagram. First step that we seen, we gone through the fixed end moment. We calculated the fixed end moment for each span. Then we seen the condition of how to find out relative stiffness under different conditions. Then we calculated the distribution factor for each member by considering internal joint. We also completed the moment distribution table by considering frame as non-sway frame. Even though it is a sway frame, first we have to do the analysis by considering treating it as a non-sway frame, and then we find out the final end moment for each span. Now this is the second part of a problem, and here we are going for the sway frame analysis. Now same problem, now we have to do its sway analysis. So for that, let's consider the vertical column and apply the sway or the translation to the column. So there is a sway in the right hand side, and let's consider that sway is a positive. So whatever the moment created due to the sway, that moment for AB is 6 EI delta divided by L square, and for column the sway moment will be 6 EI by delta divided by L square. L is a column length. Now due to this sway moment, find out the relation of this sway moment which is happen at that particular end due to the sway delta. So what we have to perform, that we have to assume that the column are going to sway toward the right hand side, and due to that sway, the whatever the moment generate, that moment we have to consider for that end B and C. So these are the moment which are generated at the end B and C. Now let's consider its ratio. So moment MAB divided by moment CD. So by taking that ratio, putting the value, considering delta will be same for the both column. So by putting the value other values, 6 EI into delta, now the length of column AB is 4 square into divided by MCD, that is a 6 EI delta divided by L square. Now putting the value of L for the second column is 2 meter, and moment of inertia for the column second column is 2I. So putting this value, we have MAB divided by CD is equal to 4 divided by 32, that means 1 divided by 8. Now let assume some value for that MAB and MCD in proportionate that 1 by 8. So let's consider MAB is a 10 kilonewton meter. If it is a 10, and let assume also it is in anti-clockwise direction. So if it is a 10, according to this ratio, if MAB is 1, then MCD will be 8 times of that. So it become 80 kilonewton meter. You may take any value 20, 30 likewise. Let assume here 10. So and also it is also in an anti-clockwise direction. Okay, so this is a step uh, when we are doing the sway analysis. First we have to do we have to consider non-sway frame, and then in second stage you have to consider it as a sway frame and find out the relation of end moment by applying the sway. Now do the moment distribution method. So consider write down the moment distribution table. First joint is A, then next is B joint, then C, and last one is joint D. So member AB connecting to A, member BA and BC connecting to B, member CB and CD connecting to joint C, and last member D, that is connecting to member DC, joint D. Then distribution factor. Now the distribution factor for internal joint 0.2, 0.8, and for internal joint C 0.5 and 0.5. This we seen in a first video. Then fixed moment, this also we seen in the first video. For AB is 10, for BA is 10, for BC it is the moment calculated previously by keeping the column fixed and applying the translation in the toward the right hand side. Whatever the moment generated, that we calculated as 10 for AB, and for BA it is 10. For CD it is 80, and for DC it is 80. So these are the fixed end moment. After treating a column end as a fix, we translate it toward the right hand side. So these are the moment, fixed end moment for the column. This moment distribution table is only specifically for the column, because we are doing the analysis, sway analysis for the column. So put the value related to that column. Then balancing. Now there is a fixed end at the both end A and D. The column is fixed, so there is no need of a balancing will not be there. Then the next is initial moment. So whatever the fixed end moment, the balance moment is 0, so same will be a fixed initial moment. Then after that we have to look toward the internal joint. Now at internal joint the moment BA moment is 10. So to come up to the 0 moment or equilibrium condition, we have to apply the correction -10. So -10 into distribution factor 0.2, we have -2 distribution moment, -10 correcting moment into 0.8 distribution factor, we have distribution moment for BC is equal to -8. Now look at the internal joint C, the moment coming 80. So to maintain the equilibrium, we have to apply the correcting moment -80. So +80 and -80 is equal to come out to be 0, and it will maintain the stability or equilibrium condition. So correcting moment is -80 into distribution factor CB become -40 distribution moment for CB. Correcting moment -80 into distribution factor of a CD 0.5 come out to be -40 distribution moment. Now do the half carry over toward the far end. So -2 divided by 2 become -1, -8 divided by 2 become -4, -40 divided by 2 become -20, and -40 divided by 2 become -20. After carry over, we have to do the distribution. We have to look toward the internal joint. So at internal joint, the moment is minus 20 for B, and for C it is minus 4. So we have to apply plus 20 as correcting moment. So plus 20 into distribution factor become 4 and 16. Now plus 4 into distribution factor 0.5 become 2. So these are distribution moment. Now do the half carry over at the far end. Half you have to carry at the far end. So there is a fixed support, so half moment will be carried at the far end. So 4 divided by 2 become 2. Then it will be here, it is 1. 2 divided by 2, 16 divided by 2 become 8. Now again look toward the internal joint. So again we have to apply minus 1 as a correcting moment. So minus 1 into this distribution factor, we have minus 0.2 and minus 0.8. This one is a minus. Then for 8 into this distribution factor, we have minus 4 and minus 4. Half we have to carry at the far end. So it become minus 0.1. It become minus 0.4. This is become minus 2, and this is at the far, at the last end, at end D it is minus 2. Again we have to do the distribution. So here we have to apply the correcting moment, plus 2 into distribution factor 0.2 become plus 0.4, plus 2 become plus 2 into 0.8 distribution factor become 1.6 positive. Then 0.4 plus 0.4 into 0.5 become 0.2 and 0.2. Again we have to do the carry over. Half we have to carry at the far end, and we have 0.2, 0.1, 0.8 and 0.1. Then after that again we have to do the distribution moment. So distribution again point minus you have to take here. Now minus 1 into minus into 0.2 become minus 0.02, minus 1 into 0.8 become minus 0.080, minus 80 into 0.5 become minus 0.4 and minus 0.4. So this value come out to be less or 0.0 something. So we have to stop here after distribution. So we have conducted the iteration, first iteration, second, third and fourth. So 4 iteration we have did, and after the distribution moment we have to, let's stop here, then do the addition of initial moment up to the distribution moment. We have final moment 11.10, then plus 12.18 for joint B, and at joint C 37.80, and for joint D the value come out 59.10. So to get it, you have to add all the value from the initial moment up to the distribution moment. All value, consider their sign, add all the value to come up at the final moment. Let's stop here. Remaining part will be continued in the next video. Thank you.